Please join me in welcoming to the stage Mr. Staffan Truvé, co-founder and CTO of Recorded Future. His demo today will focus on the future of AI for threat intelligence to reduce operational risk.
Hello, good afternoon, everyone. It's great to see that some people are still left. It's always challenging to be at the end of the day like this. So I'm going to talk about how we use threat intel, how we build threat intel and consume it with AI. So let me state the obvious. We live in extremely exciting times these days, as we all know. The fact that machines are increasing, Moore's law is still doing its work, whereas we humans, every 100 years there might be a good mutation. A good mutation, but otherwise, nothing much happening with us. So of course, we're inevitably coming to the point where machines will overtake us in performance in essentially all tasks, I would say. Which is not saying that humans are not needed, it's just that we're going to change how we work. So that's the good news, if you like. But then, of course, the world has become a pretty terrible place the last few years. We have more wars popping up, we have terrorism, natural disasters, climate crisis. And then we have all the cyber threats, which are emerging both from criminals and from nation-state actors. And finally, we have attacks on our brains, influence operations of various kinds. So we're seeing a world today where we have multidimensional threat picture. And the bad news now is, of course, that AI is a powerful tool for good, but it's also a great tool for bad. So in all these dimensions, we're seeing AI helping the threat actors increase their efficiency, coming up with new ways of attacking. Everything from smart weapons to automated cyber attacks. And of course, what most people are thinking about when we talk about AI as a threat, deepfakes and threats both to individuals, companies, and our nation's democracies. So I think as a sort of overall theme of this is that we need to figure out how we can use AI against evil. There's a separate talk to talk about how regulators need to realize that we need to regulate in the right way to avoid the bad guys from just staying ahead. But if we look at the defending side, the challenges we have, you can sort of group them in three categories, I think. First one is that to stay on top of threats today, you need to look at so much data. It's coming in at such volumes, at such speed that it's unmanageable. You cannot do this with humans only. You need to automate. Secondly, there's a huge skills shortage. I think the last number I saw is that we have a shortage of about 3.7 million cyber threat analyst professionals globally. And the third thing is, of course, that the threat actors are highly motivated, whether they are commercial criminals or if they're state-sponsored, they're highly motivated, they have good funding, and they have access to exactly the same technologies as we do on the defending side. So these things together really mean that we need AI to do intelligence, to do threat intelligence in an efficient way. Because if you look at a modern cyber attack, and I'm going to be brief on this, anyone who's interested, please contact me afterwards. I'm very happy to share my slides and so on. A modern cyber attack, if you want to defend against that, you need to look at the attack vectors. So most, for example, ransomware attacks today take place not by criminals breaking in, they actually unlock the door and walk in because there are billions of stolen credentials circulating on the internet. So essentially you go out, you buy credentials, you buy access, you get in and you start stealing data, encrypting systems and so on. So you need threat intelligence to see if there are leaks in your security systems, meaning that you lose credentials. Similarly, if you want to understand if someone is currently attacking and exploiting your systems, you need to monitor traffic both on your local networks and externally. So we built up a system in sort of a tiny part of our system where we collect network traffic data between known command and control nodes for malware and organizations and countries' systems. So essentially you could think of this as mapping out end-to-end what does the internet look like, what infrastructure is being used by the bad guys, that's the red here, the blue is the good guys, the companies and organizations we want to defend, and then of course in between there's the rest of the internet essentially, which has not yet been characterized as red or blue, you could say. So our ambition, we started out doing this 2007, started our company 2009, ridiculously ambitious, you might say, with the goal of organizing everything on the internet. And when we say everything here, it's everything from the technical core of the internet, so keeping track of every single IP address, domain, as I said, gathering traffic where it's legal to do that, keeping track of the domain name system, certificates, credentials. So that's sort of the sort of technical core of the internet. Then we're also looking at code. So we're tracking good code by looking at code repositories, seeing if there are weaknesses in open source code, if people are accidentally uploading clear text passwords into GitHub and other places, things like that. We're monitoring the bad code. So we're today analyzing hundreds of thousands of samples every day of malware to be able to understand how they work. And that's also how we extract, for example, information about what are the current command and control nodes, the IP addresses used by the malware to contact their makers to understand what to do. And finally, the content of the internet, so text, images, videos, and so on. So the ambition we had was to organize this as a threat-oriented digital twin of the whole internet. And we store that in something we call the intelligence graph. For those of you who are into old-style AI, this is a knowledge graph representation of what's happening in the world. So we have hundreds of billions of relationships between tens of billions of entities. So this is everything from every single geographic location on Earth, which has a name, people, companies, organizations, technologies, malware, threat actors, etc., you name it. So huge graph, which is updated in real time. That's one of the big challenges here, is that you cannot do like people do with large language models. Every year you retrain the model and you always have old data. This has to be real time to help defend against real-time threats. So think of this huge graph, which you then have billions of agents working on. Essentially, we're building agents which can go in and keep track of threat levels down to, for example, the physical risk if you're in a specific city in the world, the specific cyber risk associated with a company or with an IP address or a domain, and so forth. And of course, the big challenge now becomes instead, how do you present this to humans in a good way? And I'll talk about this in two steps. The first one is that the part we spent the first 12 years of the company building. That is, how do you visualize this kind of information so that a human analyst can make use of it? And the second one will be, how can we now use generative AI to help the analyst consume this data? So here's a simple example of what an interface in our system. I hope you can see the screen here is pretty small, but essentially you go into the system, you query and say, show me malicious network traffic where the source node is in the US. And for a couple of days, you typically get a few tens, maybe 50, 100,000 IP addresses. And on top of that, you'd also get things like the risk scoring here. So you'll see a risk score associated with a specific individual IP based on the kind of malware it's associated with, the volume of traffic being exfiltrated through that IP address, and so on. Similarly, if you want to keep track of the risk of the products you're using, we're doing real-time risk scoring of something like 3 billion entities. So these are about 5 million companies, and then billions of IP addresses, domains, and also products and technologies. So if you're, for example, using ChatGPT or other technologies, you can subscribe to updates on the risk level associated with that particular product. And if there's an incident, like in this case, you'll be alerted. And at the current moment, we typically have a human user then deciding to, for example, shut down or temporarily do something else to remedy the threat to that. So these are sort of tracking entities, but then we also, in this graph, keep track of events. So for example, we keep track of every documented cyber attack. So what you can do is, in the graph, is you can go in and say, find me all cyber attacks being written about anywhere, and if there's an identified target and a method used for the attack, you can filter on that. So in this case, I asked for all references to cyber attacks over the last couple of weeks, where the target was some company which we have tagged as part of the banking industry. And then I decided to split it up here over different attack vectors, so you have DDoS, ransomware, and so forth. So this is a great way, for example, to do trend analysis. You could split this more. You could color this by geography, for example. So if you're let's say, a bank in Southern Europe, you can ask specifically, let me see the trends for how cyber attacks are targeting banks in Southern Europe and which methods are being used to do that. But still, there's so much information. So the next thing we try to do is to personalize this information. So here's an example of that. This is something we call a threat map. So this is for a specific organization. In this case, it's our own company. We're tracking about 5,000 threat actors globally. In this case, what we're doing is we're showing on the x-axis the ability every single threat actor has to attack our organization. So that's based on the graph's information about what are the tools, which malware does this threat actor have, and how does that intersect with the technologies I'm using. So how capable are they of attacking me? And on the y-axis, it's the intent. So that looks at, for a threat actor, who have they attacked traditionally, what geographies, what industries, etc. And thereby we can give an estimate of how interested they would be. And of course, like in all management consultant diagrams, you want to focus on the upper right corner, because these are guys who are both willing and able to attack us. So that's where you should spend your time and energy on increasing your defenses. So we don't only do cyber, we think geopolitical threats are equally important, and in particular, as I mentioned, these threats tend to come together. So in a similar fashion, you can go in and say, let's have a timeline over the amount of protests occurring in the US. No surprise to anyone, it looks bad at the moment. You can see, of course, you could drill down here and see what locations. On the right here, I have a heat map of the US showing where are the most reported protests over the last couple of days. You can actually extend this into the future as well, because one of the good things about things like protests is that people tend to use the internet to organize them, so you can actually use that to have an idea of what's being planned. That's the simplest way to predict the future, is to actually hear what people are planning to do. And in many cases, these things are accompanied by cyber attacks. So by checking the activity of physical protests, you can actually get an early indicator of the risk of, for example, hacktivist attack. The Gaza war has been a great example of that, a sad but great example of how these things actually track each other, and you can use one to predict the other. So that's how we spent the first 13 years of the company, essentially organizing information and visualizing in good ways. So that's the left side of this diagram here, essentially, bringing the information, turning it into a structured graph representation. And then the last couple of years, of course, generative AI has given us new possibilities. I think overall, though, as we're in the midst of all this deep learning, large language model hype, I think it's important to notice that the system like ours consists of a lot of components which are machine learning based. But on top of that, we very often end up having very old-fashioned rule-based logic systems. And I think as I look more and more in different AI-based systems, you always tend to get a structure like this. If you haven't read the book Thinking Fast and Slow by Kahneman, which talks about these two ways of doing AI, I think it's well worth time spent reading that to get an idea about how you can combine big-scale machine learning with logic. So as we look at it now, and this is a bit of a sort of afterthought construction, but I think our work on AI has really been divided into 4 different phases, and I'll go through them quickly now since we don't have much time. So the first one, which we spent many years on, is really using AI to organize data, to build the intelligence graph. So what we do there is we use natural language processing, for example, to take text, not only the Queen's English, but very often very poor English from tweets and other places and, Russian dark websites and stuff like that, and extracting information about what are the entities and events being talked about. And then when we do that, we sort of organize it in terms of frames, another very old-fashioned AI technology where you say that for a cyber attack, the things you want to identify is the attacker, the target, the method, and a few other parameters. And this then constitutes the nodes and the links that we have in the intelligence graph. We also do something we call temporal analytics. So we look for any data on the internet, when was it published, and what temporal expressions are in there. So if someone, for example, says that in 2 days I plan to start a protest outside the White House, if it's the 8th today, then you know that that's going to end up on the 10th on the timeline. So it's a great way to see what's being talked about the future, but it's also a great way to filter out historic events which you might not be that interested in. Way too much on the internet is talking about old stuff. Similarly, we look at images, and for images, what we do is that we use them in many different ways. So one example is we do screenshots of web pages, and then we use computer vision to extract logotypes. So when someone registers a fake website for Bank of America, for example, we detect that, the domain registration. We then go and take a screenshot, and if the fake website with a typo-squat URL actually has a logo of Bank of America, then you know that that's probably the preparation for a phishing attack of some kind. And so we can alert and get that taken down. We also do other magic with images. Two things I'd like to highlight. One is that we built a very fancy model for doing location from images. So essentially you can send in an image and you'll get an estimate of the latitude and longitude. Where in the world was this image taken? A great way to actually localize things which you care about as an analyst. And the last example of image analytics is that we use another index to actually be able to search perceptually for similarities in images. One thing you can do that for is you can, for example, take this. This is a recent example, someone claiming that there was, the student at Columbia couldn't spell Palestine correctly. Turns out that was a small piece of fake news because they actually took a picture from Ottawa and then claimed it. But in our system, we could actually backtrack and find the original source and sort that out. That was phase one. Phase two is helping the analysts get insights. And what we've done is that we've taken the previous model where we built visualizations, and then on top of that, we put a large language model, which allows us to automatically create reports. This looks pretty simple, but it's been a huge time saver. So analysts say that what used to take them 5-6 hours can now be done in less than 1 hour. Key thing here is, of course, to make this trustworthy. So we built tools for detecting hallucination, so we can actually guarantee that there's no hallucination. And we also do attribution, so we tell people how... 1 minute left, I know. So that we can actually give the analyst the direct sources to the underlying data used to build the report, which is exactly what's needed to create trustworthiness for these things. And then, of course, next natural step is to do dialogues. So now you can have a dialogue like a ChatGPT, but instead in here we have real-time data. So you actually have the access through a RAG architecture to the real-time data combined with the reasoning capabilities of a large language model. So you can go in and ask things like military activity around Taiwan. You can actually do analysis. You can actually go in and have a sort of hypothetical reasoning. And I think people who are afraid of hallucinating models, I always like to show examples like this where we do hallucination for good. So if you ask the large language model, how could this situation evolve? It's actually going to speculate in a pretty constructive way. And of course, when you ask this, you know as an analyst that this is hypothetical. That means that you need to pay more attention. It's your job to decide which of these possible scenarios are relevant and interesting. But it turns out humans are much better at criticizing other people's work than doing original work themselves. So just having the help of getting these suggested alternatives actually speeds up the analyst's job quite significantly. And finally, of course, what's going to happen is the next step now, which we're hoping I'm be back here next year to talk about that, is that we'll be automating this. So you'll be able to assign an AI-based agent, which is going to monitor stuff for you and then come back and report as new things happen. And I'm definitely out of time, so I should just say that we're working from the start with a vision of building what we call centaurs, the combination of human and an AI analyst. And I think it's really exciting that we're at an age right now where you can actually build these things for real. Thank you.